This conference will now be recorded.
I think that's what it's called.
I understand.
Yeah.
Okay, son. So let's begin. And this was the question where you got stuck, and this is the review or exam exercise of irrational equations, commonly known as surds equations. So it says it's a 6-mark question from 2014. Okay, question number 9, paper 2-1. There it says that integers a and b are such that there you are having an irrational equation here, so given, where a and b are the integers. We need to find the possible values of a and the corresponding values of b. Okay, so how we are going to do that, that's something that we need to find. So how we are going to handle this, first of all, we'll expand this equation. Okay, and then we'll collect the irrational terms on one side and rational terms on the other side, and then we'll try to sort it out. So
Okay.
let's try to do that. Let's try to see. Okay, this is the nice question we are having, the 6-mark question. So be very generous in your solution work. No need to skip any step here. Okay, so now here you see this is your irrational equation given to us. We'll try to give it a nice form. How we're going to give it a nice form? Just expand this a plus 3 root 5 whole square by using your formula of a plus b whole square. Okay, so you're going to use this formula. This is your algebraic identity. So this is your a square plus 2a. This is your b plus b whole square. Okay, 3 root 5 is the b here. Okay, this plus a minus b root 5 I'm going to copy as it is, equals to 51. Okay, now it's going to be a square plus 6 root 5a. Okay, plus, now once when I apply square on 3 root 5, what it is going to give me?
9 times 5, which is 45 plus 50.
Yeah, so it's going to be 45 plus a minus b root 5. How about if I just bring this 51 over here, like that, and then it's my square. Okay, now a square plus, now see, I'm going to collect all the terms which are containing a along with it. So you see, this is the term and this is another term. So if I just try to write my a common outside, then the coefficients of this term is 6 under root 5 plus 1. Okay, there you go. 45 minus 51, what it gives? 45 minus 51, what it gives you?
Yes,
Negative 6.
minus 6. Yep.
Minus 6 minus b root 5 equals to 0. Now you see, you are they are asking you to find the values of a and b in this question, right? There are two unknowns. Okay, So once there are two unknowns, it means I need two equations. But over here in this situation, I've been given just one equation. So what to do? Okay. So I have to make some logical adjustment here. And what would be that adjustment? If I just say that I am going to assume that let b is a constant number, then this full thing is going to be considered as a constant part. Are you getting it?
Mm-hmm.
So but it's not going to help us out. Let me just try to write the terms involving under root 5 on one side and the terms involving I mean terms without root 5 on one side. Let me just try to organize the values like this, because if I just go according to this pattern, it is not going to help me out. Okay. So if I just say that, let me just remove this. If I just say that, let me just write the original terms as this. Okay. Now this is the term involving root 5. This is another term involving root 5. Fine. So okay, and this is the part. And I'm just shifting this minus b under root 5 over here. It looks something like this. Okay. Now on the right side, you see you are having just one term, b root 5, and there is no other term uh, which is not containing under root 5. So there's something 0 here, okay, which is not containing root 5. So the term which is not containing root 5 is nowhere, which means it is 0. Fine. So if I just compare the terms involving root 5 and try to form one equation, so once when I compare the coefficients of root 5, I just assume that let root 5 is a variable. Okay. So comparing the coefficients of variable root 5, just try to take it in that sense. I'm not asking you to write this statement. I'm just writing for understanding. Okay.
Okay.
Coefficients of root 5. Root 5 is considered as a variable here, just to form an equation. Are you getting it? So this thing
Yep.
tells me that 6a is the coefficient of root 5. Okay. Equals to, and over here the coefficient of root 5 is b. I just compared the coefficients of my root 5. It is giving me one equation and equation number 1. And the other equation means the terms which are not involving root 5 are these. Okay, so they are forming another equation. Are you getting my point? So in
Yep.
this way, you just got the two equations here. Now with the help of equation number 2, factorize. Either use quadratic formula or you use midterm breaking. Get the two factors, get the two values of your a. Tell me what they are. Once when you get the two values of your a, substitute them one by one in your equation number 1 and you will get the corresponding b values. Okay, so let's try to factorize this equation number 2. So go ahead please. You're too good in using your midterm breaking procedure. So go ahead and tell me what the values of your a are.
Wait.
What?
No, no.
Midterm breaking? Yeah.
Midterm breaking where. Uh, Wait for the equation number 1 and 2.
Yeah. Yeah. Just pick up equation number 2, son, and
Okay.
factorize and get the two values of your a, because you see equation number 2 is containing just one variable, that is a. Right. So just try to factorize it. Get the two answers of your A here. You can see I'm doing the work. You can
Yep.
take the guidance here. And so the two answers of your A are A equals to 2 and A equals to minus 3. Alright, now once when you substitute A value 2 here in equation number 1,
Mm-hmm.
your B is 12, yeah,
Yep.
and for A equals to minus 3, your B is minus 18. Okay,
Yep.
so this thing tells that for A value 2, my B is 12. For A value 3, minus 3, my B is minus 18. Now we are going to check out our values here, that whether we have done the work correctly or not. So they have given us the answers. We can check it out. For 3.7, question number 4. Let's try to have a look. Uh, this is it. Bingo. Correct. Okay. Is it clear?
Mm. Yep.
All right. Now, the next question you asked me was 9,
Question
yeah?
9.
Okay, now this is it. It's 2016 March, question number 2, paper 1, 2, all right. Now here they have given you uh, an exponential equation involving three variables PQR. And they're asking you to find the values of A, B, and C. A, B, and C are actually present at the power position, you can see. It's a little blurry question, but this is it, okay? So we are going to pick up this question and try to find out the values of our ABC. We just grab the snapshot from here, and then we jump to the board. Okay, so this is your equation. You are well aware about the properties of your indices. You know when to add up the powers. You know when we subtract the powers. You know when we multiply the powers. So you are well aware with all that, right? And also you know what are the powers of the radicals, okay?
Mm-hmm.
If you're talking about square root, then if I try to replace this square root sign, which power I'm going to apply? I'm going to apply power half, right? You know
Yep.
each and everything. We are going to use all those key points and try to solve this question. But first of all, we just copy this equation. This is an exponential equation. Okay, so we just copy it's minus 1 upon r upon, and here I am going to replace this radical sign by my 1 by 2 power. Okay, so the power of the square root is 1 by 2. I'm going to write it down. Okay, and this is equals to your p power a, q power b, r power c. There you go. Okay, and then we're trying to solve our left hand side and give it a nice form. So we keep on copying our right hand side as it is. Okay, we're not going to touch our right hand side here, because at the end we need to compare the powers, and that's it. So over here you see it's p power minus 2, q power 1, r power minus half upon. Now this overall power half is going to be applied on all these individual powers. Okay. So as this power is overlapped, so you're going to multiply the powers. So it's going to be p times 1 by 6. Okay. 1 by 3 into 1 by 2 give you 1 by 6. q square into half give you q power 1. Yeah, and here it's going to be minus 3 by 2. Overlap powers get multiplied. That's it. And now what you're going to do, you're going to
Subtract.
you're going to move the denominator variable powers into the numerator. So they are going to be written with the opposite sign of what they are below. So I just shifted this power positive 1 by 6 above. It becomes minus 1 by 6. Q power 1, and this power 1 will go up with a negative sign I'm going to write down here. And then r power minus half, and this denominator power minus 3 by 2 will move up. It becomes plus 3 by 2. Here. And this is
Yep.
p power a, q power b, r power c. That's it. And now take the LCM of these powers here. It's going to be minus 12 minus 1 by 6. Okay, I'm not skipping any step here. So just to make you clear that we are how we take the LCM and the powers. That's how we take the LCM. So I'm not going deeper in the LCM work because it's something quite basic that we study in the junior levels. You are well aware with this, right? So
Yep.
minus 12 minus 1, negative addition, give you minus 13 by 6. Q power 0. R, give you power 1. Am I right? It's 2 by 2. 2 by 2, that is 1. So I'm writing 1, and I'm not writing any number here now because the power is 1. 1 is always invisible. So I'm not writing that. Now you see at the both sides, compare the power of the like bases. Okay, compare the powers of the like bases. Compare the powers of the like bases, like that. So you see, a is therefore minus 13 by 6. Okay, b is 0. All right, and c is 1. Okay, you can write this minus 13 by 6 in the form of a mixed fraction as well. That's something optional. You can write like this too. Okay, that's also fine. If you keep it as it is,
Yep.
that's also okay. So this is how you find the value of your ABC. Now we check our answers. Now I hope the concept is clear.
Yep.
Now we just move on, and this was question 9. We go to the answer section. Let me minimize the font a little, and then question 9. Here you go, son. That's all
Yep.
fine, all correct. Okay. And now the last question you asked me to do was 10. Yeah.
Yep.
So we just this is your question number 10. Now what they are asking us to do not use a calculator in this question. Okay, we obey them. We're not going to touch our calculators now. Okay. The diagram shows two parallelograms which are similar. Similar, remember, they are not congruent, they are similar. Okay. Interior angles are equal, but the sides are having different lengths. Therefore, they are similar. The base and height in centimeters of each parallelogram is given to us. Show that x, that is the height of the smaller parallelogram, is p plus q root 3 by 6. Okay, here x is equals to this. Find the value of each of the integers p and q. Now, with the help of the concept of similarity, we are going to help out this question. So you know, in similar figures, the ratio of the corresponding sides are always same, right? We are going to take the help of that. Alright, so we just take a snapshot of this beauty. Go back to the board. Okay. So see, if I just say that I am the ratio of the heights of the similar figure is equals to ratio of the corresponding bases. Okay, that's it. So let me further minimize this a little. Okay, now that's fine. Okay, I just represent heights by h1 and h2. This is my figure number 1 and this is my figure number 2. Okay, the height of figure 1, height of figure 2, the ratio of the heights is equals to ratio of the corresponding base. And make sure if you are using figure 1 in the numerator, then all numerators of the different ratios must maintain the same layout, okay, the same arrangement. Okay? Make sure that you are focusing on this thing. Now you see height 1 is 1 plus 3 root 3 upon h2 is x, okay, equals to b1 is 6 plus 2 root 3 upon b2 is 5 minus root 3. Clear? You know how to
Yep.
multiply rational numbers, irrational numbers. You know how to rationalize the irrational number. You know both things, right? Now I'm going to arrange this equation in such a way that I'm keeping my x as a subject. Okay, I move my x here, I move this number here, and this number over here. Okay, how it looks like. X is going to look something like this. Yeah, that's it. Now you know how to multiply the numerator factors. They are irrational factors. So you know how to multiply. So it's just like how you multiply your algebraic factors. The methodology is same. Okay. And then it looks like 5 minus root 3 plus 15 root 3 minus 9. Yeah.
Okay.
So it is giving me 4 5 minus 9 give me minus 4.
-4.
Okay. Plus 15 minus 1 give me 14. Yeah.
14
Root
root 3. Yeah.
upon. Now you see from the numerator as well as from the denominator, I can take out 2 common outside, both from the numerator and denominator terms. I can take it out. So my objective is to make it as simpler as possible. So I'm just doing it. I just took out my 2 from here. It's giving me minus 2 plus 7 root 3. And from the denominator as well, 2 is the HCF, so take it out. It's 3 plus root 3. That's what I'm having.
Yep.
This 2 and this 2 will get cancelled. Now I'm having a very simpler form. Minus 2 plus 7 root 3 upon 3 plus root 3. Now you see in the question, they say that x is equals to p plus q under root 3 upon 6. In the denominator, you are having a rational number, okay? So here we are having a rational number in the denominator, 3 plus root 3. We have to get rid of this, okay? So we are going to rationalize this result. So I'm going to divide and multiply by 3 root 3 here. Wait a second, please.
Okay.
Okay, so it's 2 plus 7 root 3 upon 3 plus 3 root 3. I'm going to multiply it with 3 minus root 3. Okay. Whatever the sign I have here, I just take sign opposite of this while dividing and multiplying during rationalization. Yeah. So now multiply numerator with the numerator and denominator with the denominator. What you're going to get? In the denominator, you're just taking the help of your a square minus b square concept. So it's a minus b and a plus b. So just took the help of this. Just multiply these two irrational numbers in the numerator and tell me what the result is.
Okay. Wait, in the numerator and denominator?
Just multiply these two irrational factors. Tell me what they are going to give you.
They give minus 27 plus 23 root 3.
Minus 27 plus 23 root 3
3.
upon 6. You see, 9 minus 3 is 6,
6.
right? So this is your x. Okay, this is your x, and x, this was your x. So x was p plus q root 3 by 6. So at the place of my x, I'm now going to write p plus q root 3 by 6. So once when I compare this number with this result, I'm going to get my p and q. P is minus 27, okay, and q is 23. Okay, now we are going to check this out. There you go. That's correct. Okay. So that's how we handle exam pattern questions relating to irrational equations which are basically called surds equations. So that's how we do. I hope this is clear now.
Yeah.
Okay. Okay guys, so if you find this video helpful, please subscribe to my channel, hit on the like and share this video as much as you can with your friends and other learners so they will also get helped. I'll see you then soon with some other precious video. Till then, just take good care of yourself, study well, score good. Allah Hafiz.